Hello, welcome back to the channel. Today we have a question on board, that is 3 to the power x is equal to x to the power 9. Now this is a common Olympiad maths question. Now how do we go about finding the value of x? Now to start with, first of all, we need to sort numbers to one side and variables to another side. Now let's start. So I can rewrite this expression as x to the power 9 is equal to 3 to the power x. Now the next step, I can have x to the power 9 to be equal to 3 to the power x. Now what I'm going to do is I'm going to raise both sides to an exponent of 1 on x. I'm going to raise both sides to an exponent of 1 on x just to be able to sort numbers and variables to one side. Now when I do this, I'm going to see that this is going to leave me with x to the power 9 multiplying 1 on x is equal to 3 to the power x multiplying 1 on x. Now this will leave me with x to the power 9 multiplying 1 on x to be equal to, now this x can take away this x over here. I'm going to have 3 to the power 1. Good. Now over here we need to get rid of this 9 also if we are sorting numbers to one side. So to do that, I'm going to say that I have the expression x to the power 9 multiplying 1 on x. That entire expression raised to a power 1 on 9 to be equal to, whatsoever you do to the left hand side, I must do the same thing to the right hand side. So I'm going to have 3 to the power 1 also raised to the power 1 on 9. Good. So what I'm going to be left with is I'm going to have x to the power 9 multiplying 1 on x multiplying 1 on 9 to be equal to 3 to the power 1 multiplying 1 on 9. Now over here, the identity we use over here, or the law of indices we use over here, is when you have x to the power, or let's say when you have a to the power b all raised to the power c, that should give you a to the power bc. Now when we continue, we can see that the 9 over here can take away the 9 over here, and we'll be having x raised to an exponent of 1 on x is equal to 3 raised to an exponent 1 multiplying 1 on 9. Good. Now I can see that I'm having x to the power 1 on x to be equal to, now this 1 over here, I can rewrite this 1. Now to do that, I can say that this is 3 raised to the power 3 on 3 multiplying 1 on 9. Now 3 on 3 over here is just 1, which obviously doesn't change anything. So when we continue, we see that we have x to the power 1 on x is equal to 3 to the power 3 multiplying 1 on 27. Just simple math, multiply the numerators first and then the denominators first. Okay, the denominator second. So when we do that, we are going to have x to the power 1 on x to be equal to 3 raised to the power 3 all raised to the power 1 on 27. Good. Now when we do that, we are going to have x to the power 1 on x to be equal to, now 3 to the power 3 over here is 27. So 27 raised to an exponent of 1 on 27. Good. Now, for a direct comparison, we can see that our x over here is 27 and our 1 on x over here is 1 on 27. Now, when we compare, we see that our x is equal to 27 and then our 1 on x is equal to 1 on 27. So now if our x is equal to 27, let's do this. Let's check if our the value 27 for x is correct. Now we have the expression 3 to the power x is equal to x to the power 9. So what it means is that we have 3 to the power 27 to be equal to 27 to the power 9. Okay, now we can say that this is 3 to the power 27 on the left hand side to be equal to, now instead of writing 27 over here, I can write 3 to the power 3. That's for 27, all raised to the power 9. Now when I do that, I'm going to see that 3 to the power 27 is equal to 3 raised to the power 3 over here is simply 27. So 3 raised to the power 3 multiplying 9. And when I do that, I'm going to see that 3 raised to the power 27 is equal to 3 raised to the power 3 times 9 gives us 27. That means our value for x being equal to 27 is correct.